and welcome to the morning news. Today's top story, crude oil. Crude oil is a non-renewable fuel and rapidly running out. Crude oil is a liquid fossil fuel formed from the decay of sea creatures over millions of years. Under heat, pressure and in the absence of air. It is a dark, oily, thick and smelly liquid. It is made up of a mixture of compounds called hydrocarbons. These hydrocarbons are alkanes. Alkanes are saturated hydrocarbons. This means that they don't have double bonds. We mainly use shorter alkanes for fuels as they are more flammable, have a cleaner flame and a smaller boiling point, which is better for fuels which we use them for. We also use the longer alkanes for things such as roads. Now, over to Lucy, who is looking at fractional distillation and cracking.
I am at a fractional distillation plant to look at how we separate the different alkanes from crude oil. We separate these alkanes and crude oil by a process of fractional distillation. We do this as there are many different fuels in crude oil and they all have different uses. For the oil to become useful, we need to separate it. I have Nigel, a worker at the fractional distillation plant, here to explain the whole process to us.
Well, Lucy, different alkanes have different boiling points, and this is what enables us to separate them. We heat the crude oil to a vapour. Different alkanes will have different boiling and condensing points. They then cool and condense at different times. When each molecule condenses, they will rise until they condense. The quicker they condense, the smaller the height they will condense at will be. Each of these now separated alkanes are called fractions. Some of the different fuels from crude oil are LPGs, petrol, kerosene, diesel and bitumen.
So what do we do with the alkanes after fractional distillation?
After fractional distillation, we often crack the larger molecules as we have more need for them than the smaller molecules. Cracking is the breakdown of larger alkanes into smaller alkenes. The gasoline fraction is in high demand for petrol in cars, so to get more we break down the big molecules by heating, often in the presence of a catalyst, something that speeds up our reaction. By cracking, the products are unsaturated, have double bonds and are not alkanes anymore but alkenes. The double bonds are between the carbon atoms in the alkenes. An example of this is medicinal paraffin. Medicinal paraffin is the mix of two hydrocarbons. We crack it by heating it and passing the vapour over small pieces of broken pot. The pot acts as a catalyst. To see if the cracking has worked, we often test for double bonds. We do this with bromine water. If there aren't any double bonds and the product is unsaturated, the bromine water will go colourless. But if there aren't any double bonds and the product of the cracking is saturated, then the bromine water won't change, it will just stay orange.
Thank you, Nigel. Back to you in the studio, Natalie.
Thank you, Lucy, for that interesting explanation. Now we are going to look at plastics. Plastics are made from crude oil as well, and are another big use for it as well as fuels. After cracking the large alkanes, we can polymerise them to create long chains, plastics. To explain this in more detail, Lucy spoke to an expert, Mickey.
I am here with Mickey, who is going to explain to us what polymerisation is and why do we have to do it. Well, it makes plastics, and what would we do without plastic? Plastic has become a big part of our daily lives. We have come to take them for granted. Without it, we would not have the simplest things like plastic bags and food containers. But without it, we would not have the most of things we use today. So, Mickey, what is polymerisation?
Thanks, Lucy. Polymerisation is when double bonds break in lots of monomers. They join together to form a long-chain polymer. Polymers are very long chains of 50,000 plus molecules of an alkene. The monomers have to have double bonds, otherwise there will be no bonds between the monomers. An example of a polymer is polyethylene, which is the plastic in plastic bags. This is a polymer made of many molecules of ethane. When we polymerise propene, we make polypropene, which we use for plastic crates and ropes. An interesting polymer, in my opinion, is polytetrafluoroethene, which is made up of the monomer tetrafluoroethene and is used for the non-stick on frying pans.
Thank you for explaining that, Mickey. So, there are different types of plastic?
Yes, one type of plastic is thermosoftening. These are plastics which melt easily. This is because there are weak forces between the chains, which gives them a low melting point. They are also recyclable because they melt easily and so are used for things like plastic bags and drink bottles. Another type of plastic is thermosetting. These burn and char when heated rather than melt. This is because there are strong cross-links between chains, which hold them in a fixed position. My favourite type of plastics, though, are smart polymers. These are polymers with a unique quality, different to others such as hydrogels in nappies, which absorb the liquid.
Thank you, Mickey. Plastics are non-biodegradable, so they're not broken down naturally by microorganisms. After we've used plastics, we have 4 options. We can burn it, which creates energy, heat energy, which we can use to heat buildings, but by doing this we are also releasing toxic gases. We can reuse the plastic, we can also recycle it, changing it into something else which preserves resources and makes landfill sites smaller. It saves energy as well. The last option we have is to bury it. Landfill, which is not good. Back to you in the studio, Natalie.
Thank you, Lucy. That is all we have time for. Today we have learnt that crude oil is not just a dark, viscous liquid, but a big supply of fuels and our only supply of plastics. Tomorrow we will be looking at alternative fuels, what they are and why we are using them. Thanks to Lucy, Mickey and Nigel, and thanks to you for watching. We hope you've learnt something. Goodbye.